The American company Taro Dynamics has unveiled an innovative unmanned aerial vehicle called the XP-4, which revolutionizes the concept of vertical takeoff drones with its groundbreaking transwing technology. This aircraft is capable of folding and unfolding its wings mid-flight, transforming from a compact vertical structure into a fully winged airplane. The XP-4 is being developed in close partnership with the United States Navy as part of the Blue Water Maritime Logistics Program. In environments without traditional landing strips, the XP-4's vertical takeoff and precise landing capabilities make it a game changer. Additionally, it can travel several hundred kilometers and transport cargo weighing between 20 to 25 kilograms. The Pentagon has already expressed interest in this development, and in the near future, the XP-4 may become a versatile platform for both military and humanitarian operations. April 2025 marked a pivotal moment in the evolution of global military aviation, as China unveiled its newest and most advanced fighter jet, the J-50. This sixth-generation aircraft has already begun to send shockwaves through the world's military command centers, raising alarms across major defense forces. The J-50 is not merely an advancement, it represents a quantum leap in air superiority technology. More than just a successor to the J-20, the J-50 is a fully realized sixth-generation fighter that China has been developing, in total secrecy for over a decade. The project, led by the Chinese aerospace giant AVIC, was done in close partnership with military research institutions and artificial intelligence centers. The J-50 is equipped with autonomous flight capabilities, meaning it can operate without a pilot or in a human-AI mode, where the system aids the pilot in making split-second, high-stakes decisions. In addition, the jet has the ability to command and coordinate drone swarms, transforming it into an airborne command center on its own. Among the groundbreaking features tested were active camouflage systems. These onboard panels can adjust their visual properties, significantly complicating enemy detection efforts. Satellite data also revealed that the J-50's test flight lasted 47 minutes, during which it demonstrated the use of a hypersonic missile previously hidden under the Dark Sword program. Another notable test involved cyber defense capabilities, where the fighter successfully defended against a real-time electronic attack, neutralizing the threat without any damage. With the J-50, China has decisively entered the race for air dominance, setting a new standard in aerial warfare technology. American engineers are determined to maintain their leadership in cutting-edge developments, refusing to relinquish any ground to China in this field. Engineers working on the DARPA project have recently showcased the sixth field test involving combat swarm systems. This initiative aims to refine offensive strategies using drone swarms in urban and other complex, dynamic environments, all while in mid-flight. During the test, the drones autonomously mapped the terrain, identifying key features like buildings, windows, passageways, staircases, and potential hiding spots. Each module within the swarm can be reprogrammed in real time through an intuitive interface, allowing operators, regardless of their programming expertise, to quickly assign new tactical objectives with simple visual commands. The results of the experiment highlight that multi-level offensive operations, which do not require direct human involvement in combat, are already feasible. The swarm can secure buildings, control perimeters, block enemy escape routes, and even adapt to shifting conditions or mission updates in real time. On your screens now, you're witnessing one of the most impressive forms of vertical logistics used by the United States Armed Forces, the external transportation of heavy equipment via military helicopters. The footage shows a heavy-lift transport helicopter from the U.S. Marine Corps, capable of carrying external loads weighing between 14 to 16 tons. The equipment is secured to specialized cables and sling attachment points beneath the helicopter's fuselage. Once the load is securely fastened, the helicopter lifts vertically, hoisting the cargo off the ground, then transports it through the air to its designated drop-off location. There, it is gently lowered to the ground. The entire process unfolds in several steps. First, the loading zone is prepared. Next, the equipment is positioned, and the cargo is secured to the sling cables. A final safety inspection is conducted by the helicopter at low altitude. Once all checks are complete, the helicopter slowly lifts the load, detaching it from the ground and beginning its transport route. The U.S. military is continuously enhancing its capabilities through cutting-edge technologies, with the introduction of a new generation of combat drones. One of these advanced systems is the TCAD, developed by Duke Robotics. This unmanned aerial vehicle, UAV, uniquely combines drone technology with firearms, allowing it to perform tasks that were once the domain of ground units. The TCAD is equipped with a stabilized platform designed to support various types of firearms, including rifles and light machine guns. Thanks to its active stabilization system, the drone can accurately engage targets while in flight, reducing recoil and ensuring high precision. The TCAD's primary mission is to provide tactical support for troops during urban combat and conduct operations in hard-to-reach areas. The Chinese military is actively preparing for the future of warfare, and alongside testing the latest fighter jets. Engineers at Kestrel Dynamics, a leading company in coordinated unmanned aviation, have unveiled a new swarm of military drones. The demonstration featured the Kestrel KD-12 micro-drones, compact and highly maneuverable units designed for complex missions. In a stunning display, more than 60 drones took off simultaneously as part of an autonomous swarm, all operating independently without centralized control. Each drone is linked into a self-organizing mesh network, enabling the swarm to interact with surrounding devices and rapidly adapt to changes in the environment. At the heart of the drone's intelligent behavior is a distributed neural network architecture, trained in simulated scenarios to ensure flexibility and precision. The Core 12 drones are capable of analyzing the actions of nearby units, forming intricate three-dimensional formations, and adjusting their flight paths in real time. The swarm can make autonomous decisions, select a leader, assign roles, and carry out missions, even if the connection to the ground station is lost. The Chinese military has introduced a unique aerial attack platform, light autogyros armed with anti-tank missiles. These compact aircraft, known as the Hunting Eagle Strike Gyrocopter, were developed by Shanghai Beijing Special Vehicles specifically for the People's Liberation Army of China. The autogyro is a two-seat aircraft with tandem seating in an open cockpit, designed for quick, agile operations. It's powered by a pusher propeller and features a two-blade main rotor with an 8.4-meter diameter. The power plant is an Austrian Rotax 914 engine, generating 115 horsepower, which enables a maximum takeoff weight of around 560 kilograms and a payload capacity of up to 270 kilograms. Additionally, there are three-seat versions equipped with a more powerful engine and increased fuel capacity, designed for both airborne and transport missions. One of the standout features of these autogyros is their ability to carry 4 anti-tank guided missiles, transforming them into light, highly mobile strike platforms. What you're seeing is rare footage of the first parachute jump preparations by cadets of the People's Liberation Army of China. This moment isn't just a routine task, it marks a significant milestone in their training, one that signals their transition into a new phase both mentally and physically, as well as professionally, before they're cleared for a real jump from an aircraft. The cadets undergo extensive and rigorous training in the early stages. They start on simulators, where special equipment mimics the entire jump process, from exiting the airplane, deploying the parachute, to landing. They focus on mastering the proper body positions, maintaining control in the air, and following the correct procedures in emergency situations. The highlight of this preparation is their first actual exit from an aircraft. When the moment for the jump comes, following the instructor's command, the soldiers exit the aircraft one by one. The parachute automatically deploys with the help of a static line, and once the canopy is open, the cadets take control of their descent, using the steering lines. The final, most critical part of the jump is a safe and controlled landing in a designated drop zone, where instructors immediately assess the precision, technique, and overall execution of the maneuver. The first jump is more than just a milestone in a military career, it's a personal challenge. This experience forms the bedrock for discipline, psychological resilience. Let's shift our focus to the United States, where you're watching exclusive footage of the training process for elite airborne units of the U.S. Army, specifically the 82nd and 101st Airborne Divisions. The jumps are being conducted from the cargo bay of a C-17 Globemaster III, a heavy military transport aircraft, over the Sicily drop zone at Fort Bragg Military Base in North Carolina. This type of jump is known as a static line jump. Unlike freefall jumps, the parachute of each soldier is automatically deployed as they exit the aircraft. A static line connected to an anchor cable inside the plane pulls the deployment pin, releasing the parachute. This system ensures quick, synchronized canopy deployment for the entire group of paratroopers, crucial for large-scale airborne operations in tightly controlled airspace. In the footage, you can see the C-17 Globemaster III ascending, with a line of paratroopers packed tightly inside, all prepared for the jump. The C-17 is a versatile strategic transport aircraft capable of deploying both cargo and personnel via airdrop, using either the rear cargo ramp or side doors, as seen in this instance, at an altitude of approximately 1,200 to 1,500 feet. The doors open, and on command, the soldiers begin exiting one by one. The timing, airspeed, and intervals between each jumper are meticulously calculated. Once outside the plane, each paratrooper immediately feels the tug of their open canopy and begins a controlled descent toward the target zone. For the soldiers of the 82nd and 101st Airborne Divisions, these jumps are a routine part of their training, keeping them combat-ready at all times. The Chinese military has introduced a cutting-edge reconnaissance drone, called the Recon Bird, designed to mimic a real bird in both appearance and flight patterns. This innovative UAV is equipped with flapping wings, enabling it to glide through the air undetected and blend effortlessly into natural surroundings. The Recon Bird is built for discreet surveillance, intelligence collection, and monitoring sensitive areas. It features high-resolution cameras, real-time data transmission, and is capable of operating around the clock, utilizing infrared sensors for nighttime missions. Its bird-like design and natural flight movements allow it to avoid detection by both humans and most air defense systems, making it an effective tool for covert operations. Sichuan Tendon Sci-Tech Innovation, a state-owned Chinese company, has unveiled its new heavy military cargo drone, which has generated significant international attention. Resembling a compact twin-propeller turboprop aircraft, the drone is one of China's most advanced unmanned aerial vehicles, UAVs, to be fully developed domestically. Named the Tangent 765, it successfully completed its first test flight in August 2024 at an airfield in Sichuan Province. The Tangent 765 is powered by two robust engines, providing exceptional stability and enabling precise low-altitude flights. Its design allows for takeoff from short runways, and its high level of automation, combined with a satellite navigation system, enables remote control without the need for an on-site operator. Next in line is the Turkish army, which has introduced its first combat drone, the Sungut, developed by ASASGuard. This compact yet formidable unmanned aerial vehicle is capable of performing both reconnaissance and precision combat missions. The Sungut stands out for its unique design, featuring a fire stabilization system that ensures accurate targeting and shooting, even during intense vibrations or while in motion. In its standard configuration, the drone is equipped with an automatic rifle of a specific caliber and can carry up to 200 rounds of ammunition. There are also variants with a 6-barreled 40mm grenade launcher, modules for deploying munitions, a night vision system, and a laser rangefinder. The drone can be operated remotely by an operator at distances of up to 10 kilometers and can also work in coordination with other drones. Currently, the Sungut is actively deployed in border security, anti-terrorism operations, and in providing support to ground forces. Next, we turn to one of the most impressive and technically demanding aspects of modern airborne logistics, the airdrop of military vehicles. In this operation, 8 Army Humvee vehicles were dropped from the cargo hold of a C-17 Globemaster III, a heavy transport aircraft. The mission was carried out by U.S. Air Force personnel from the 16th Airlift Squadron, based at Joint Base Charleston in South Carolina. The designated drop zone was the renowned Fort Bragg Training Ground in North Carolina. This operation falls under the category of heavy equipment and vehicle aerial delivery, utilizing parachute systems. The primary goal of such drops is to quickly supply and deploy military hardware to areas where ground transport is either impractical or undesirable. The airdrop follows a precise sequence. First, the cargo is secured to a specialized platform designed for aerial delivery. The platform is then loaded into the aircraft and fastened in the cargo hold. Upon reaching the drop zone, the rear ramp of the aircraft is opened, and the extraction parachute pulls the platform out. Once the platform exits the aircraft, the main parachutes deploy, slowing its descent and ensuring a safe landing for the cargo. Meanwhile, drones have become a critical asset in some of the most intense military conflicts worldwide. Recently, the Ukrainian armed forces have introduced a new weapon, a flamethrower drone. Since the start of the year, Ukraine's Ministry of Defense has shared videos on social media showing the drone unleashing a torrent of fire over forested areas where Russian units are hidden. This fiery effect is caused by a chemical reaction involving molten metal. The drone's ammunition contains a thermite mixture of aluminum powder and iron oxide, which burns at temperatures reaching up to 2,200 degrees Celsius. This intense heat is capable of destroying almost any material, including steel, and is particularly effective against forests, trenches, and military equipment. The Russian military has acknowledged the serious threat posed by this weapon. The thermite mixture burns through positions and forest cover, which previously shielded Russian forces. The footage shared online clearly demonstrates the devastating impact of the Ukrainian flamethrower drone in action, making it a formidable weapon in modern warfare.